Still an angle of elevation and depression. Let's check this other problem here real quick. A person stands on the top of a cliff 40 meters high and looks down at a boat. And then the angle of depression to the boat is 35 degrees. Now let's check. Let's try to draw. We have a horizontal line here. And then down here inside water, there is this boat here. Now this is the boat down there inside water. This boat is in water. Now we have a person who is standing here and then looking to the boat down there. And then the angle of depression, which is the angle of looking down, it's 35 degrees here. 35 degrees. And then the person is standing. Now this person, we are told that he is standing on a cliff, which means from the ground here. From the ground to the person up there. This is going to be 40 meters. Now let's try to find the horizontal distance from the boat to the base of the cliff. We want the horizontal distance from the boat. This distance from the boat, here is a boat from here to the base of the cliff. That's the distance we are looking for. Let's call it a x. Now let's check. Before we go, this angle together with this angle down here, they are equal. This is the angle of depression. This one is the angle of depression, and this one I'm highlighting in red is the angle of elevation. And they are equal since they are alternate interior angles. So this one is 35 degrees too. So now we have a right angled triangle here. So we can apply the SOHCAHTOA. That's a right angled triangle. Now let's check. We have an angle on the right angled triangle. It's 35. We also have an opposite side, which is 40 meters. And then we also have an adjacent side, which is nothing but x. Now from there, OA, it's tan. 35. This is equals to the opposite, it's 40 over x. Now multiply by x on both sides, x tan 35 will be equals to 40 because the denominator x will be cancelled out by the x you are multiplying by on both sides. Now divide both sides by tan 35. You are going to get that your x is equals to 40 divided by tan 35. Put our working here. so that we can bring in our calculator here. Now we want to calculate 40 divided by tan 35. It's giving us 57.1. 57.1 meters. And that's the solution. Next question. Now they are integrating bearings and trigonometry. Now let's check this one. A ship sails 8 kilometers east, then 6 kilometers north. Find the bearing of the ship from its starting point and the distance between the 2 points. So let's try to understand this question. We have a ship. Maybe let me put it down here. There's our ship. It sails, or rather it moves 8 kilometers east. So it's moving from where it started, and then it's moving for 8 kilometers. 8 kilometers to the east. Then after that, it then moves 6 kilometers to the north. From here, it's going straight north for a distance of 6 kilometers. Now, please note that east and north, they are perpendicular to each other. So it's actually 90 degrees here. This is 90 degrees. Now, where is the ship? The ship is now here at this point. That's where the ship is. Then what is the question saying? Find the bearing of the ship from its starting point. So from here, what's the angle to that one there? The bearing of the ship from its starting point. So you are going to find the bearing. Just draw a knot line on from the starting point. This is the starting point, and that's where it ended. So at this point now, which is the starting point, let's go and draw our knot line. There you go. And then we want to find the angle between the knot line moving clockwise to where the ship is. So we are actually looking for this angle here. Remember, we are moving clockwise to find the bearing. So that's the angle we are looking for. So considering the fact that this knot line is parallel to this 6 kilometer side there, that simply means that this angle here is equals to that angle there, because they are alternate interior angles. This is equals to that. That's why I'm calling them x. Now let's try to find the value of x. So to find the value of x, our angle, it's x. And then opposite to the angle, it's 8. Then adjacent, it's 6. Now still we're using tan. So tan will be equals to tan will be equals to the opposite, it's 8 over the adjacent, which is 6. This is supposed to be tan x. Let's come and write it down here so that we have a space for our calculator. Nice one. Then your x is now going to be equals to the arc tan 8 over 6. What's arc tan 8 on 6? Shift tan 8 on 6. It's 53.1 degrees. So your x is equals to 53.1 degrees. And then the bearing, we use 3 figures. So the bearing is going to be 0.53 degrees. Like that. Next, let's try to find the distance between the 2 points, between the starting point and the end. That's actually the hypotenuse of a right angled triangle. So to find the hypotenuse, just say the hypotenuse squared is equals to the sum of the square of the other two sides. And then your hypotenuse squared, which is y, is equals to 8 squared is 64. Plus then 6 squared is 36. Then your y squared is equals to 64 plus 36. That's giving me 100. So you take the square root on both sides, you are getting that your y is nothing but 10 meters. Sorry, kilometers. And that's the distance between the 2 points. Next question, which is problem number 5. 2 angles of elevation. Now from a point on the ground, the angle of elevation to the top of the tower is from the point on the ground. Let's try to draw the point, the ground first. This is our ground. And then from a point on the ground, this is a point on the ground. And then to the top of a tower. To the top of a tower, here is our tower. From a point on the ground to, from here to there. The angle of elevation, the angle of looking up, the angle of elevation is equals to 30 degrees. Now, moving 20 meters closer. So if we decide to move 20 meters closer, that means that now the point, it's no longer here, it's now here. Still we going to the top of the tower, the angles become 45. The angle becomes 45. This angle becomes 45. If we move 20 meters, this distance here, from here up to here, it's 20. So if I decide to call this whole distance from here to here, if I decide to call this distance from the point to the base of the tower, if I decide to call that one distance x, this is distance x. That simply means that now from here to here, from the base of the tower to the second position, it's going to be x. It's x minus 20. That's the distance. Now what do they want us to find? They find the height of the tower. We want to find height h. Let's try. We are going to make two equations there and then solve. From the first triangle, let me try to highlight it in blue. From this triangle, what do we have? We have an angle of 80 degrees, and then opposite to the angle is nothing but our h, and then adjacent to the angle it's our x. Now we have OA, that's tan. So our tan AD is equals to the opposite, that's h over x. Now let's try to make x the subject there. X will be equals to h over tan 30. Now let's leave that and call it equation 1. Let's put it somewhere there. Now let's work on the other triangle, the smaller triangle. Now on the smaller triangle, we have an angle of 45 degrees. And then we also have an adjacent side, which is x minus 20. Also have a hypotenuse, the opposite side. Opposite is nothing but our h. Now still we are using the tan. So your tan 45 is equals to opposite, it's h over the adjacent, it's x minus 20. Now from there, let's try to substitute now here. We need to substitute equation 1 into this one. You are going to get that your tan 45 is equals to h over x, it's h over tan 30. Then this is minus 20. Maybe let me take this to a kind of a friendly working space. Let's take it to a friendly working space so that we can try to deal with this thing. Let's try this one. I'm gonna try to zoom. Okay, let's try this. Feel like it's kind of not looking fine. So for this thing, and put it into the formula. We have tan 45 is equals to h over we have something like this. Let's try to solve for h from that. Let's try to work on the denominator. So the denominator is going to be h. We have an h on the numerator and then it's over h minus 20 tan 30 and this should be over tan 30. Hope you've noticed what we've done here. 20 it's over 1 and then the LCD between tan 30 and 1 is tan 30. So if you divide tan 30 into tan 30, it's 1 times h, you are getting this h here. Then minus 1 into tan 30 is tan 30 times 20, you are getting 20 tan 30 over that. And that's how we got this one. Now let's try to so this now the h is being divided by the whole of this. So in other words, it's being multiplied by the reciprocal of that. So we are having an h multiplied by, instead of divide, the reciprocal of that. And then the reciprocal is tan 30 over h minus 20 tan 30. So in other words, this is what we have here now. We have a tan 45 is equals to h. So let's do this. H tan 30. H tan 30 over h minus 20 tan 30. Now from there, let's just cross multiply the cross multiplication. Remember this one, it's over 1. It's over 1. So if we cross multiply, we are going to get something like this. We are going to get h tan 45 minus 20 tan 30 tan 45 equals to h tan 30. Now let's take the h to the other side, the h tan 45 to the other side. So if it jumps the equal sign, it changes sign. So it's going to be negative 20 tan 30 tan 45 is equals to h tan 30 minus h tan 45. Then from there, let's factorize the tan, the h on both sides, on both terms. On the right, we are getting h into tan 30 minus tan 45. This is equals to the negative 20 tan 30 times tan 45. Then from there, let's divide both sides by tan 30 minus tan 45. So we are getting that our h is equals to negative 20 tan 30 tan 45 over tan 30 minus tan 45. Yes, we should use our calculator for that. Then you are going to get the value of your h. Let's try to bring in our calculator here. There you go. There is our calculator there. We just need to do the necessary calculation. Negative 20 tan 30 tan 45 over tan 30 minus tan 45. And then there is the answer there, which is 27.3. The answer we are getting is 27.3. Let's just write it, 27.3. Yes, it's meters. And that was it on this tutorial. Stay tuned for more.